Okay. Once again, good afternoon, all of you. So, in yesterday's lecture, we have started the unit number 3, that is radiation. So, in that, we have seen different points. So, first point we have discussed as a what is meant by radiation. So, radiation is nothing but transfer of energy in the form of electromagnetic waves. What is meant by radiation? Radiation is nothing but transfer of energy in the form of electromagnetic waves. That is nothing but radiation. Then, what are the different properties of the radiation? That is, radiation heat transfer does not require any medium. Then, radiation heat transfer occurs most effectively in vacuum. It obeys the laws of the light. Then electromagnetic waves travel at the speed of the light in the vacuum. So what is the speed of the light? That is 3 into 10 raised to 8. Okay. Then what is the relation between wavelength and frequency? That is lambda is equal to c upon nu. Then we have discussed about the how to calculate the energy. That is energy is equal to h into nu. So h into c upon lambda. By using that, we have to calculate the energy of the photon. Then we have seen the different types of the electromagnetic radiation. That is gamma rays are there, X-rays are there, ultraviolet ray, infrared radiation, visible radiation, thermal radiation, microwave radiation. So what is the relation between that? If wavelength is higher, at that time frequency will be less, and if wavelength is less, then temperature will be higher. So gamma rays having wavelength is less, so having energy is higher because energy is inversely proportional to the wavelength. Okay, so gamma rays having less wavelength is there, so energy of gamma rays is higher. Okay, so after that we have discussed the next point as a different properties of the radiation, that is absorptivity, reflectivity and transmissivity. Okay, so in that incident radiation is nothing but capital G, reflected radiation is Gr, then absorbed radiation Ga, and transmitted radiation is nothing but Gt. Then what is meant by incident radiation? That is total incident radiation on surface from all direction per unit time and per unit area. That is nothing but incident radiation. It is denoted by capital G, and it is expressed as a watt per meter square. Watt per meter square. Then we have defined the what is meant by absorptivity. Absorptivity is nothing but it is the ratio of absorbed radiation divided by incident radiation. Similarly, we have defined for the reflectivity. Reflectivity is nothing but reflected radiation upon incident radiation. Then what is meant by transmissivity? Transmissivity is nothing but transmitted radiation divided by incident radiation. So from that we get the one relation, that is alpha plus rho plus tau is equal to 1. Alpha is nothing but absorptivity, rho is nothing but reflectivity, and tau is nothing but transmissivity. So addition of these three is nothing but that value is nothing but 1. After that we have discussed about the concept of the black body. So what is meant by black body? Black body is nothing but is one which neither reflects nor transmits any part of the incident radiation, but it absorbs all of it. Okay, so for the black body, alpha is equal to 1, rho is equal to 0, and tau is equal to 0. So a perfect black body does not exist. Okay, after that we have discussed about the opaque body. So what is meant by opaque body? When no incident radiation is transmitted through the body. Okay, when no incident radiation is transmitted through the body, it is called as an opaque body. Means the body having transmissivity is 0, so tau is equal to 0. That body is nothing but opaque body. So from that we get the relation as a alpha plus rho is equal to 1, and example for the opaque body is that is nothing but glasses. Okay, then we have discussed about the white body. So what is meant by white body? If all the incident radiation falling on the body are reflected, if all the incident radiation falling on the body are reflected, it is called as a white body. So for white body, reflectivity is equal to 1, means rho is equal to 1, and alpha is equal to 0, tau is equal to 0. So we get the equation as a rho is equal to 1. Okay, and reflections are having two types, that is regular reflection and diffuse reflection. So if incident radiation is equal to incident radiation angle is equal to the reflected radiation angle, then we said that that reflection is nothing but regular reflection. And what are the examples for the regular reflection? If the surface is highly polished or smooth surface, at that time regular reflection will be produces. And what about the diffuse radiation? Diffuse radiation is nothing but in diffuse reflection all incident beam is reflected in all direction. Okay, this is about the regular reflection and diffuse reflection. After that we have discussed about the concept of the black body. That is the same concept, that is a black body is an object that absorbs all the radiant energy reaching its surface, means alpha is equal to 1. Okay, So what are the properties of the black body? It absorbs all the incident radiation falling on it. It emits maximum amount of thermal radiation, and it is diffuse emitter. So we have considered the one hollow hollow enclosure, and that hollow enclosure we have considered as a approximate black body because it absorbs the maximum radiation incident on it. Okay, so this hollow enclosure is used for the calibration of the heat flux gauges, then thermometers and other radiometric devices. Okay, after that we have discussed about the laws of the radiation. In that first law we have discussed, that is Stefan-Boltzmann law. What is the first law of radiation? That is Stefan-Boltzmann law. Okay, so we have discussed about the Stefan-Boltzmann law. So what is the Stefan-Boltzmann law? The law states that the emissive power of a black body is directly proportional to the fourth power of its absolute temperature. So Eb is directly proportional to T raised to 4. Then what is proportionality constant? That is Stefan-Boltzmann constant. And what is the value of Stefan-Boltzmann constant? That is 5 into 667 into 10 raised to minus 8 watt per meter square Kelvin raised to 4. So by putting that value, we get the equation as Eb is equal to 5.67 upon 100 raised to 4. Okay, then we have calculated the emissive power of any body. So we know that emissivity is nothing but emissive power of a body to the emissive power of a black body. So from that we get the equation as a E into epsilon into Eb. So from that we get the equation for the emissive power of any body. That is notation for emissive power of any body is capital E. So we get the equation as a into epsilon into sigma into T raised to 4. By using that we have to calculate the emissive power of any body, and for black body we have to calculate Eb is equal to sigma into T raised to 4. Okay, then we have discussed about the Kirchhoff's law. What is meant by Kirchhoff's law? Kirchhoff's law states that the emissivity of body is equal to absorptivity when the body remains in thermal equilibrium with the its surrounding. म्हणजे जर दोन बॉडी असतील, दोन बॉडी थर्मल इक्विलिब्रियम मध्ये असतील तर त्याचा अर्थ काय असणार आहे? दोन्ही बॉडीचं टेम्परेचर सेम असणार आहे. त्यावेळेला एका बॉडीची जी ऍब्सॉल्युटिव्हिटी असणार आहे तेवढीच काय असणार आहे? इमिसिव्हिटी असणार आहे. ऍब्सॉल्युटिव्हिटी इज इक्वल टू इमिसिव्हिटी व्हेन बोथ बॉडीज आर थर्मल इक्विलिब्रियम विथ दी इच अदर. म्हणजे दोन्ही बॉडीचं टेम्परेचर सेम आहे, त्यावेळेला एका बॉडीची जी काही इमिसिव्हिटी असणार आहे तेवढीच त्या बॉडीची काय असणार आहे? ऍब्सॉल्युटिव्हिटी असणार आहे. Okay, so from that we get the equation as a alpha is equal to epsilon, that is absorptivity is equal to emissivity. Okay, so we have covered the Stefan-Boltzmann law and Kirchhoff's law. Now we have to solve one problem. So all of you write down this problem. Simple problem we have to solve. Write down the effective temperature of a body. The effective temperature of a body. All of you write down first problem, which is related to the Stefan-Boltzmann law. The effective temperature of a body, the effective temperature of a body having an area of having an area of having an area of 0.12 meter square. The effective temperature of body having an area of 0.12 meter square is 527 degrees Celsius. Is 527 degrees Celsius. Is 527 degrees Celsius. Calculate the total rate of energy emission. 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 So first of all, write down the given things. So temperature of that body is given 527 degrees Celsius. So we have to convert that temperature into Kelvin. So 527 is nothing but 800 Kelvin. Then area is given 0.12 meter square. And we have to calculate the total rate of energy emission. Okay, so what is the equation for the emissive power of a black body? That is sigma into A into T raised to 4. Okay, so if area is given, then we have to consider that area. What is the standard equation? AB is equal to sigma into T raised to 4. For this is for the unit area. If area is given, then we have to multiply by that equation by the area. So write down the equation. AB is equal to sigma into A into T raised to 4. So what is the standard value of sigma? That is Stefan-Boltzmann constant. 5.67 into 10 raised to minus 8 into area is given 0.12 and temperature is given 800 raised to 4. So from that we get the total rate of energy emission, that is 2786.9 watt. Okay, so this is the simple problem which is related to the Stefan-Boltzmann law. Okay, so in MCQ type question, this type of problem maybe arises. So all of you understand what is the emissive power of a black body, what is the formula for that, what is the Stephen Boltzmann constant, what is the value of Stephen Boltzmann constant, so that it is very easy to calculate the total rate of energy emission. Okay, total rate of energy emission. Okay, so all of you completed this problem. This is the simple problem. Now write down the second problem. Write down. Calculate the calculate the total emissive power. Calculate the total emissive power for an industrial furnace. Calculate the total emissive power. Calculate the total emissive power for an industrial furnace. For an industrial furnace. For an industrial furnace. For an industrial furnace in the form of a black body, in the form of a black body, and emitting radiation of 2500 degrees Celsius. Okay, the same problem is there, but in this case they have not given the value of area. Okay, and our aim is to calculate the total emissive power, and we have to consider this is a black body. So our equation for the emissive power of a black body, that is EB, is equal to sigma into T raised to 4. Sigma is nothing but it is the Stephen Boltzmann constant, and that value is known to us, that is 5.67 into 10 raised to minus 8. And temperature, that is 2500 degrees Celsius, we have to convert that temperature into Kelvin. So 2500 degrees Celsius we have to convert into Kelvin, that is 2773 Kelvin. Okay, put that value into equation and find out the value of total emissive power of a black body, that is EB. Okay, so in this case they have not given the value of area, so don't consider the area because we get the values in the watt per meter square. मगाशी आपण एरियाने मल्टिप्लाय केलं त्यावेळेला आपल्याला आन्सर कशामध्ये मिळालेला आहे, वॅट मध्ये मिळालेला आहे, कारण मगाशी आपल्याला एनर्जी कॅल्क्युलेट करायला सांगितलेली. एनर्जीचे युनिट काय असणार, वॅट असणार आहे. And in this case they have said that we have to calculate the emissive power, and emissive power, what is the unit of emissive power, that is watt per meter square. Okay, so EB is equal to 3.352 into 10 raised to 6 watt per meter square. So this is the Stephen Boltzmann law, that is EB is equal to sigma into T raised to 4. We have to remember this constant, Stephen Boltzmann constant value, that is 5.67 into 10 raised to minus 8. Okay, we have to remember this value, because if don't remember this value then it is not possible to calculate the emissive power of a black body. Okay, so this is the second simple problem on the Stephen Boltzmann law, that is EB is equal to sigma into T raised to 4. EB is equal to sigma into T raised to 4. Okay, so all of you return. Shall I proceed? Anyone reply in the chat box? Problem is over. Simple problem hai. Calculation करून बघा. Check the calculation whether the answer is correct or wrong. Okay, so we have covered the two laws, that is Stephen Boltzmann law and after that Kirchhoff's law. समजले का? लॉज ऑफ रेडिएशन मध्ये टोटल 4 लॉज असणार आहेत. फर्स्ट लॉ इज स्टीफन बोल्ट्झमन, सेकंड वन किर्चॉफ्स लॉ, थर्ड वन प्लँक्स लॉ and fourth one weins displacement law. Now we have covered the two laws, Stephen Boltzmann and Kirchhoff's law. Now we have to go for the third law, that is Planck's law. Okay, so all of you write down third law, which is law of radiation, that is Planck's law. Write down Planck's law. Planck's law. So what is the statement of the Planck's law? What is the statement of the Planck's law? The spectral emissive power of a black body is dependent upon absolute temperature of body and wavelength of radiation. The spectral emissive power. आता दोन प्रकारची इमिसिव्ह पॉवर असते. एक आपण जनरल म्हणतो की जनरल इमिसिव्ह पॉवर, and there is another concept that is spectral emissive power, किंवा त्याला मोनोक्रोमॅटिक इमिसिव्ह पॉवर असं म्हटलं जाते. तर इमिसिव्ह पॉवर आणि स्पेक्ट्रल इमिसिव्ह पॉवर मध्ये काय फरक आहे बघा. सो इमिसिव्ह पॉवर इज डिफाइन्ड ॲज the total amount of radiation emitted by body per unit area and per unit time. So in this case, whatever the radiation emitted by any body having different wavelengths are there, म्हणजे एखादी बॉडी आणि ती बॉडी जर रेडिएशन करत असेल तर त्याच्यामध्ये जे काही वेव्ज असणार आहे त्या वेव्हची वेव्हलेंथ जी असणार आहे ती काय असणार आहे, वेगवेगळी असणार आहे. ऍट दॅट टाइम वी हॅव टू कन्सिडर दी इमिसिव्ह पॉवर. अँड व्हॉट अबाउट दी स्पेक्ट्रल इमिसिव्ह पॉवर? सो at the spectral emissive power, whatever the body we have to considering, that body emitting the radiation, and that each radiation having wavelength is same. Okay, wavelength is same. So this is about the monochromatic or spectral emissive power, and notation is E suffix lambda. E suffix lambda म्हणजे काय असणार आहे, मोनोक्रोमॅटिक किंवा स्पेक्ट्रल इमिसिव्ह पॉवर असणार आहे. आणि नुसतं ई असेल तर त्याला आपण काय म्हणणार आहे, इमिसिव्ह पॉवर म्हणणार आहे. सो दिस स्पेक्ट्रल इमिसिव्ह पॉवर असणार आहे, एखाद्या बॉडीची जी काही स्पेक्ट्रल इमिसिव्ह पॉवर आहे of a black body is depending upon the absolute temperature of body and wavelength of radiation. म्हणजे ज्यावेळेला आपण स्पेक्ट्रल इमिसिव्ह पॉवर म्हणतो त्यावेळेला त्या बॉडीमधून जे काही रेडिएशन बाहेर पडणार आहे त्याची वेव्हलेंथ काय असणार आहे, सेम असणार आहे. ओके, so the spectral emissive power notation is E lambda. So for the black body, so we have given the E lambda into B. So is function of what? It is dependent upon the absolute temperature of that body and wavelength of the radiation. म्हणजे एखादी ब्लॅक बॉडी आहे आणि त्याची स्पेक्ट्रल इमिसिव्ह पॉवर कशावरती डिपेंड असणार आहे, तर त्या बॉडीचं टेम्परेचर आणि त्या बॉडीची वेव्हलेंथ. ओके, so E lambda B is the function of temperature and lambda. Okay, so what is the standard equation for that? That is E lambda B is equal to 2 pi c square into h lambda raised to minus 5 divided by exponential of c into h divided by lambda kt minus 1. Okay, and in the form of constant, how to write this equation? E lambda B is equal to c1 lambda raised to minus 5 divided by exponential of c2 upon lambda t minus 1. So where what is the value of c1? C1 is nothing but 2 pi c square h, and what is the value of that? That is 3.742 into 10 raised to 8 watt into micrometer raised to 4 divided by meter square. And what is the value of c2? That is c into h divided by k is equal to 1.4388 10 raised to minus 4 micrometer Kelvin. Okay, so all of you write down Planck's law. Planck's law, the spectral emissive power, the spectral emissive power of black body, the spectral emissive power of black body is dependent upon absolute temperature of body, absolute temperature of body and wavelength of radiation, and wavelength of radiation. समजले का बघा सगळ्यांना? ओके, जी काय स्पेक्ट्रल इमिसिव्ह पॉवर असणार आहे ती स्पेक्ट्रल इमिसिव्ह पॉवर त्या बॉडीच्या टेम्परेचर आणि वेव्हलेंथ वरती डिपेंड असणार आहे. ज्यावेळेला आपण स्पेक्ट्रल इमिसिव्ह पॉवर म्हणतोय त्यावेळेला त्या बॉडीमधून जी काही रेडिएशन बाहेर पडणार आहे त्याची वेव्हलेंथ काय असणार आहे, सेम असणार आणि त्या वेव्हलेंथ वरती ती इमिसिव्ह पॉवर डिपेंड असणार आहे. दिस इज द कन्सेप्ट ऑफ द प्लँक्स लॉ. सो राईट डाऊन ई लॅम्बडा बी इज द फंक्शन ऑफ टेम्परेचर अँड लॅम्बडा. Okay, E lambda B is equal to function of temperature and lambda. Then write down the standard equation for this spectral emissive power of a black body is equal to 2 pi c square h into lambda raised to minus 5 divided by exponential of c into h divided by lambda into k into t bracket complete minus 1. Okay, and in the form of constant, that is c1 and c2, how to write that equation? E lambda b is equal to c1 lambda raised to minus 5, c1 lambda raised to minus 5 divided by exponential of c2 divided by lambda t bracket complete minus 1 in the form of constant, that is c1 and c2. These are the constant. And what are the values of this constant c1 and c2? C1 is nothing but 2 pi c square into h, and what is the value of this constant? That is it is equal to 3.742 into 10 raised to 8, 3.742 into 10 raised to 8. And what is the unit of that? Watt into micrometer raised to 4 divided by meter square. This is the unit of first constant. And what is the value of C2? C2 is nothing but C into H divided by K. And what is the value of constant? That is C2 is equal to 1.4388 1.4388 into 10 raised to 4 into 10 raised to 4 micrometer Kelvin. Okay, he equation लक्षात ठेवा. And we have to remember the what is the value of C1 and C2. What is the value of C1 and C2? C1 ची value आहे 3.742 into 10 raised to 8. And what is the value of C2? 1.4388 1.4388 into 10 raised to 4 into 10 raised to 4. Okay, so up to this all of you completed. Reply me in the chat box whether you have written this Planck's law, what are the equation, what are the values of constant C1 and C2. Put the message in the chat box so that I will proceed to the next law of the radiation, that is Wien's displacement law. Planck's law समजलाय का? जी काय स्पेक्ट्रल इमिसिव्ह पॉवर आहे ती कशावरती डिपेंड असणार आहे? ऍब्सोल्यूट टेम्परेचर आणि वेव्हलेंथ वरती डिपेंड असणार आहे. त्याचं इक्वेशन काय आहे ते लिहिलेलं आहे आपण, and the equation in the form of constant also we have written, and what are the values of the constant C1 and C2 we have written. Okay, so this is about the Planck's law. This is about the Planck's law. Okay, next law, write down fourth law, Wien's displacement law. Write down next law of the radiation, that is Wien's displacement law. Next law of radiation, that is Wien's displacement law. Wien's displacement law हे ऑलरेडी तुम्ही 12वीला शिकलेला आहे radiation topic मध्ये, Wien's displacement law. So write down what is the statement of Wien's displacement law. Write down the statement. Wien's displacement law states that Wien's displacement law states that Wien's displacement law states that the product of maximum wavelength and temperature is constant. What is the Wien's statement? Product of maximum wavelength and temperature is constant. म्हणजे एखाद्या बॉडीमधून जी काही रेडिएशन बाहेर पडणार आहेत त्याची जी काही मॅक्झिमम वेव्हलेंथ आहे आणि त्या वेव्हलेंथला जे काही टेम्परेचर आहे, ह्या दोन्हीचा जर प्रोडक्ट जर आपण घेतला तर तो काय असणार आहे? कॉन्स्टंट असणार आहे. सो देर आर सो मेनी wavelengths are there, and at the peak value, maximum value into that temperature of that object is nothing but constant value is there. Okay, so from this diagram we have to understood what way the calculation should be constant, that is lambda max into T is equal to constant. म्हणजे मॅक्झिमम वेव्हलेंथ जी आहे आणि टेम्परेचर जे आहे ह्या दोन्हीचा प्रोडक्ट जर कुठल्याही लोकेशनला तुम्ही घेतला तर तो काय असणार आहे? कॉन्स्टंट असणार आहे. व्हॉट इज द मीनिंग ऑफ द Wien's displacement law? The product of maximum wavelength and temperature is constant. Okay, so lambda max into T is equal to constant. This is the equation for the Wien's displacement law. So all of you draw this diagram. At the y-axis monochromatic emissive power is there, and at the x-axis wavelength is there. Wavelength is in the micrometer. Okay, so draw that graphs for the different temperature, for the 500 Kelvin, then for the 1000 Kelvin, and for the 2000 Kelvin. Okay, lambda 1, lambda 2, and lambda 3. Okay, so lambda 1 is nothing but maximum wavelength when the temperature is 500 Kelvin. म्हणजे लॅम्बडा 1 आणि 500 चा जो काही प्रोडक्ट असणार आहे तोच प्रोडक्ट कशाचा असणार आहे? लॅम्बडा 2 आणि 1000 चा असणार आहे, आणि लॅम्बडा 3 आणि 2000 चा असणार आहे. समजले का? बघा, मॅक्झिमम वेव्हलेंथ आणि टेम्परेचर ह्या दोन्हीचा जरी प्रोडक्ट तुम्ही घेतला कुठल्याही केससाठी तर हा प्रोडक्ट काय असणार आहे? सेम असणार आहे किंवा कॉन्स्टंट असणार आहे. ओके, सो लॅम्बडा 1 इंटू 500 जर केलं तर तुम्हाला जी काय व्हॅल्यू मिळणार आहे तीच व्हॅल्यू लॅम्बडा 2 इंटू 1000 केल्यानंतर मिळणार आहे, तीच व्हॅल्यू तुम्हाला लॅम्बडा 3 इंटू 2000 केल्यानंतर मिळणार आहे. कारण तेच स्टेटमेंट आहे विन्स डिस्प्लेसमेंटचं की मॅक्झिमम वेव्हलेंथ आणि टेम्परेचरचा ज्यावेळेला तुम्ही प्रोडक्ट घेता दॅट प्रोडक्ट इज कॉन्स्टंट. ओके, जसं जसं टेम्परेचर इन्क्रीज होणार आहे तसं तसं वेव्हलेंथ काय होणार आहे? कमी होणार आहे. म्हणजे लॅम्बडा 1 ची व्हॅल्यू जास्त आहे पण टेम्परेचर कमी आहे. ओके, पण लॅम्बडा 3 चं काय आहे? लॅम्बडा 3 ची वेव्हलेंथ कमी आहे पण टेम्परेचर जास्त आहे. सो because of that the product is constant. Okay, so at the right hand side I have written if temperature is increases then wavelength is decreases, because wavelength is inversely proportional to the temperature. Wavelength is inversely proportional to the temperature, that is lambda 1 is greater than lambda 2 is greater than lambda 3. Okay, so all of you draw this diagram. ओके, जी काय वेव्हलेंथ आहे आणि जे काय टेम्परेचर आहे हा प्रोडक्ट जो असणार आहे तो सेम असणार आहे. ओके, दिस इज दी विन्स डिस्प्लेसमेंट लॉ. ओके, so diagram is over. Put that message in the chat box so that I will proceed. तर ह्या कॉन्स्टंटची व्हॅल्यू काय असते त्याच्यासाठी काय आहे तर एक डेरिव्हेशन आहे. हाऊ टू कॅल्क्युलेट द व्हॅल्यू ऑफ दॅट कॉन्स्टंट. एनीवन नोज दॅट व्हॉट इज द व्हॅल्यू ऑफ दिस कॉन्स्टंट? एनीवन? तर त्या कॉन्स्टंटची व्हॅल्यू काय असते कोणाला माहिती आहे का? एनीवन? लॅम्बडा मॅक्स इंटू टी इज इक्वल टू कॉन्स्टंट. व्हॉट इज द व्हॅल्यू ऑफ दॅट कॉन्स्टंट? Anyone? What is the value of that constant lambda max into t? What is the value of that constant? Put that message in the chat box. What is the value of constant? Okay, so that constant is nothing but 2898 micrometer Kelvin. This is the value of the constant. We have to solving the derivation for that and we get that value of constant. Okay, so all of you completed this diagram. I will proceed. Shall I proceed? Anyone? Reply in the chat box. Okay. So lambda 1, lambda 2, lambda 3, temperatures are there 500 Kelvin, 1000 Kelvin, 2000 Kelvin, and lambda max into T is equal to constant. If temperature is increases, wavelength is decreases because wavelength is inversely proportional to the temperature. So lambda 1 is greater than lambda 2 is greater than lambda 3. Okay. So write down next statement lambda max into T. What is that value of constant? That is 2898 micrometer Kelvin. What is the value of constant? 2898 micrometer Kelvin. 2898 micrometer Kelvin. Okay. So we know that what is the equation for the spectral emissive power of a black body is equal to C1 lambda raised to minus 5 divided by exponential of C2 divided by lambda T ब्रॅकेट कंप्लीट -1. मगाशीच आपण प्लँक्स लॉ मध्ये बघितलेला आहे. व्हॉट इज द इक्वेशन फॉर दिस प्लँक्स लॉ? E लॅम्बडा बी इज इक्वल टू C1 लॅम्बडा रेस टू -5 divided by exponential of C2 divided by lambda t bracket complete -1. Okay, so this emissive power of a spectral emissive power of black body is maximum. की बॉडी हे इमिसिव्ह पॉवर मॅक्झिमम आहे असं आपण कधी म्हणणार आहे ज्यावेळेला डिनॉमिनेटर मिनिमम असणार आहे. and how to calculate the minimum value of the denominator? We have to take the derivative of the denominator and we have to with respect to wavelength and we have to equate that value to the 0. Okay, so E lambda b becomes maximum. E lambda b becomes maximum when E lambda b becomes maximum when we have to take the derivative with respect to lambda and equate that value to the 0. ओके, किंवा आपण डेरिव्हेटिव्ह घेणार आहे. सो टेक द डेरिव्हेटिव्ह ऑफ दॅट ई लॅम्बडा बी. ई लॅम्बडा बी मॅक्झिमम कधी असणार आहे तर त्यावेळेला त्याचं डेरिव्हेटिव्ह आपण 0 कन्सिडर करतोय म्हणजे आपण त्या पूर्ण टर्मचं डेरिव्हेटिव्ह घेणार आहे. सो डेरिव्हेटिव्ह ऑफ ई लॅम्बडा बी विथ रिस्पेक्ट टू लॅम्बडा इज इक्वल टू 0. सो वी हॅव टू टेक द डेरिव्हेटिव्ह ऑफ दॅट होल टर्म विथ रिस्पेक्ट टू लॅम्बडा. सो डी अपॉन डी लॅम्बडा of that term, that is C1 into lambda raised to -5 divided by exponential of C2 divided by lambda into t -1 is equal to 0. So we have to take the derivative of this and find out the value of or find out the equation. As a derivative घ्या d upon d lambda into bracket C1 lambda raised to -5 C1 lambda raised to -5 divided by exponential of C2 divided by lambda t bracket complete -1 bracket complete is equal to 0. त्याचं डेरिव्हेटिव्ह घ्या सगळ्यांनी. काय डेरिव्हेटिव्ह सांगा? तर न्यूमरेटरला पण लॅम्बडा आहे आणि डिनॉमिनेटरला पण लॅम्बडा आहे. सो विच लॉ हॅव टू यूज फॉर द कॅल्क्युलेटिंग द डेरिव्हेटिव्ह? जे काही डिवायडेडचा रूल आहे बाय युजिंग दॅट वी हॅव टू कॅल्क्युलेट दी डेरिव्हेटिव्ह. ओके, डिनॉमिनेटर इंटू डेरिव्हेटिव्ह ऑफ न्यूमरेटर मायनस numerator into derivative of denominator divided by denominator square. This is the equation by using that we have to calculate the derivative of this term. ज्यावेळेला व्हेरिएबल न्यूमरेटर आणि डिनॉमिनेटरला असणार आहे त्यावेळेला आपण काय करणार आहे, डिवायडेशनचा लॉ यूज करणार आहे. आणि व्हॉट इज दॅट लॉ? दॅट इज denominator into derivative of numerator minus numerator into derivative of denominator divided by denominator square, and we have to equate that value to the 0. Okay, so denominator, what is the value of denominator? That is exponential of c2 lambda t minus 1 into derivative of numerator. Numeratorचं डेरिव्हेटिव्ह काय असणार आहे, -5 into c1 lambda raised to -6 minus numerator, what is the value of numerator? That is c1 lambda raised to -5, and take the derivative of denominator. So exponential of c2 lambda t into c2 by t into bracket -1 upon lambda square, -1 upon lambda square. Okay, divided by denominator square. So what is the denominator? Exponential of c2 upon lambda t minus 1 bracket square is equal to 0. ओके, इथे कॉर्नर मध्ये तुम्हाला एक व्हॅल्यू दिसत नाही, c2 अपॉन t इंटू ब्रॅकेट, ब्रॅकेट मध्ये काय आहे तर -1 अपॉन लॅम्बडा स्क्वेअर आहे, लक्षात ठेवा. इन द ब्रॅकेट -1 अपॉन लॅम्बडा स्क्वेअर इज देअर, डिवायडेड बाय एक्सपोनेन्शियल ऑफ c2 अपॉन लॅम्बडा t -1 ब्रॅकेट स्क्वेअर. ओके, तर तुम्हाला डेरिव्हेशनचे रूल माहिती असतील तर त्या रूल नुसार आपण हे डेरिव्हेटिव्ह कॅल्क्युलेट केलेलं आहे. डिनॉमिनेटर इंटू डेरिव्हेटिव्ह ऑफ न्यूमरेटर minus numerator into derivative of denominator divided by denominator square. This is the law for this. By using that law we have calculated the derivative of this term. We have to equate that value to the 0. Denominator जर right hand side ला घेतला तर काय होणार आहे, 0 होणार आहे. So write down the whatever the terms which is at the numerator. So -5 into c1 lambda raised to -6 exponential of c2 upon lambda t plus ब्रॅकेट मध्ये मल्टिप्लाय करा, त्या एक -5 c1 lambda raised to -6 न ब्रॅकेटला मल्टिप्लाय करा, then we get this term that is 5 into c1 lambda raised to -6 plus, and what is the next term, c1 c2 lambda raised to -5 1 upon lambda raised to t exponential of c2 upon lambda t is equal to 0. ओके, जो काय न्यूमरेटर आहे तो फक्त सिम्प्लिफाय करा, then we get the equation as a -5 c1 lambda raised to -6 exponential of c2 divided by lambda t bracket complete plus 5 into c1 lambda raised to -6 plus c1 c2 lambda raised to -5 into 1 upon lambda square t exponential of c2 upon lambda t is equal to 0, is equal to 0. Okay, so this is the simplified equation. So dividing both sides by 5 c1 lambda raised to -6, दोन्ही साइडला आपण कशाने डिवाइड करणार आहे, we have to divide by the 5 c1 lambda raised to -6, then we get the equation as a minus exponential of c2 upon lambda t minus exponential of c2 upon lambda t plus 1 upon 5 c2 1 upon lambda t exponential of c2 upon lambda t is equal to 0, is equal to 0. is equal to 0. समजले का बघा, सिम्प्लिफाय करायचं आहे, त्याच्यानंतर सिम्प्लिफाय केल्यानंतर इक्वेशनला डिवाइड करा बोथ साइड बाय द 5 into c1 lambda raised to -6, then we get the equation as a minus exponential of c2 upon lambda t plus 1 upon 5 c2 1 upon lambda t exponential of c2 upon lambda t is equal to 0. तर आता हे इक्वेशन सॉल्व्ह करणं शक्य नाही, तर हे आपण कसं सॉल्व्ह करू शकतो, बाय युजिंग दी ट्रायल अँड एरर मेथड, trial and error method. So by solving this equation by trial and error method, we get the value of c2 upon lambda t. Okay, we have to find out the value of c2 upon lambda t. म्हणजे आपल्याला काय करायचं, c2 upon lambda t ची व्हॅल्यू ट्रायल आणि एरर मेथडनं पुट करायची आहे. ज्यावेळेला व्हॅल्यू 0 येईल त्यावेळेची जी काही c2 upon lambda t ची व्हॅल्यू असणार आहे ती व्हॅल्यू म्हणजे काय असणार आहे, तर ते ट्रायल आणि एरर मेथड वरून मिळालेली व्हॅल्यू असणार आहे. सो बाय write down the below, solving this equation by trial and error method, solving this equation by trial and error method, solving this equation by trial and error method. The trial and error method ने तुम्ही सॉल्व केलं तर तुम्हाला काय इक्वेशन मिळणार आहे, c2 upon lambda t is equal to c2 upon lambda t is equal to c2 upon lambda is nothing but we have to consider the maximum wavelength. So lambda max into T is equal to 4.965. The trial and error method ने तुम्ही हे equation solve केलं, then we get the value for the C2 upon lambda T is equal to 4.965. C2 upon lambda max into T is equal to 4.965. Okay, so from this lambda max into T is equal to C2 upon 4.965, and we know the value of C2. So what is the value of C2? In the Planck's law, we have written the value of C2, that is 1.439 into 10 raised to 4. Okay, so put the value of C2, that is 1.439 into 10 raised to 4 divided by 4.965. And what is the unit of numerator? That is micrometer Kelvin. So from this calculation we get the value of that constant. So lambda max into T is equal to 2898 micrometer Kelvin. समजले? तर हे डेरिवेशन वरून आपल्याला मिळालेली व्हॅल्यू आहे कॉन्स्टंटची. ती कॉन्स्टंटची व्हॅल्यू काय असणार आहे? 2898 micrometer Kelvin. Okay, so all of you remember this value of constant and unit of that. Okay, micrometer Kelvin मध्ये ही व्हॅल्यू असणार आहे. Okay, 2898 micrometer Kelvin. So this is the equation for the Wiens displacement law. Maximum wavelength आणि टेम्परेचरचा जो काय प्रोडक्ट असणार आहे तो कॉन्स्टंट असणार आहे. म्हणजे कुठलीही वेव्हलेंथ कन्सिडर केलं आणि त्याचं टेम्परेचर कन्सिडर केलं तर त्या दोन्हीचा प्रोडक्ट हा 2898च असणार आहे. दिस इज दी Wiens displacement law. Okay, this is the Wiens displacement law. Then write down the, after that equation we have to write down a combination of Planck's law and Wiens displacement law. A combination of Planck's law and Wiens displacement law. A combination of Planck's law and Wiens displacement law yields the condition for the maximum monochromatic emissive power. A combination of Planck's law and Wiens displacement law yields the condition for the maximum monochromatic emissive power for a black body. तर ह्या दोन्ही इक्वेशनचं जर कॉम्बिनेशन केलं तर आपल्याला काय मिळणार आहे? जी काय मोनोक्रोमॅटिक इमिसिव्ह पॉवर असणार आहे ब्लॅक बॉडीची त्याची व्हॅल्यू आपल्याला मिळणार आहे. सो हाऊ टू गेट दॅट व्हॅल्यू? मोनोक्रोमॅटिक इमिसिव्ह पॉवर ऑफ ए ब्लॅक बॉडी, that is E lambda B of maximum is equal to C1 lambda max raised to -5 divided by exponential of C2 lambda max into T -1. म्हणजे लॅम्बडाच्या जागेला आपण लॅम्बडा मॅक्स कन्सिडर करणार आहे. And we have to putting that value into this equation and we have to find out the E lambda B maximum value. Okay, so we know that what is the value of C1. So put that value of C1. Put that value of C1, that is 0.374 into 10 raised to -15. मगाशी जी आपण C1 ची व्हॅल्यू घेतलेली आहे त्याचं युनिट वेगळं आहे, इथं आपण वेगळ्या युनिट मध्ये घेतलेलं आहे. सो बिकॉज ऑफ दॅट 0.374 into 10 raised to -15 divided by into what is the value of lambda max. So from the above equation instead of lambda max काय लिहू शकतो आपण? 2.893 into 10 raised to -3 divided by T. ओके, मीटर केल्विन मध्ये आपण घेतलेला आहे, लक्षात ठेवा. मायक्रोमीटरचं कन्वर्जन आपण मीटर मध्ये केलेलं आहे. सो फॉर दॅट 2.898 into 10 raised to -3 divided by T is there. Okay, and divided by exponential of C2. So we know that what is the value of C2, that is 1.43 into 10 raised to -2 because we have converted into micrometer into meter and divided by lambda max into T. So what is the value of lambda max into T? That is 2.89 into 10 raised to -3. Okay, मायक्रोमीटरचं कन्वर्जन मीटर मध्ये केलेलं आहे त्यामुळे तुम्हाला ह्या व्हॅल्यूज वेगळ्या दिसतील. तर ते कशामुळे चेंज झालेलं आहे? बिकॉज ऑफ दी वी हॅव कन्वर्टेड दी मायक्रोमीटर इनटू दी मीटर. So therefore the all values are changed. म्हणजे 374 असेल तर तिथं 0.374 10 raised to -15 असं जे झालेलं आहे ते कशामुळे झालेलं आहे? तर we have converted the micrometer into the meter. So from the calculation we get the maximum monochromatic emissive power of a black body, that is E lambda B of maximum is equal to, we get the equation as a 1.285 into 10 raised to -5 T raised to 5. लक्षात ठेवा, T raised to 5 हा टी ची व्हॅल्यू आपल्याला माहित नाही, त्यामुळे टीच्या फॉर्म मध्ये आपल्याला इक्वेशन मिळणार आहे. सो व्हॉट इज दॅट इक्वेशन? ई लॅम्बडा बी ऑफ मॅक्झिमम व्हॅल्यू इज इक्वल टू 1.285 into 10 raised to minus 5 t raised to 5 watt per meter square. T raised to 5 watt per meter square per meter wavelength. Per meter wavelength. समजले? मॅक्झिमम मोनोक्रोमॅटिक इमिसिव्ह पॉवर ऑफ ए ब्लॅक बॉडीज इक्वेशन काय येणार आहे? ई लॅम्बडा बी मॅक्स इज इक्वल टू 1.285 into 10 raised to minus 5 t raised to 5 watt per meter square per meter wavelength. तर पर मीटर वेव्हलेंथ तुम्हाला दिसत नाही, तर वॅट पर मीटर स्क्वेअरच्या नंतर काय लिहा? पर मीटर वेव्हलेंथ. पर मीटर वेव्हलेंथ. तर ज्या वेळेला तुम्हाला ई लॅम्बडा बी मॅक्स कॅल्क्युलेट करायचा आहे, तर त्यावेळेला तुम्ही हे इक्वेशन यूज करायचं आहे 1.285 इंटू 10 रेस टू मायनस 5 टी रेस टू 5. म्हणजे टेम्परेचर दिलं असेल तर टेम्परेचरची व्हॅल्यू पुट करायची आणि तुम्हाला डायरेक्टली काय मिळणार आहे? मॅक्झिमम मोनोक्रोमॅटिक इमिसिव्ह पॉवर ऑफ ए ब्लॅक बॉडी. मॅक्झिमम मोनोक्रोमॅटिक इमिसिव्ह पॉवर ऑफ ए ब्लॅक बॉडी. ओके, सगळ्यांनी लिहून घ्या इक्वेशन. ओके, काय इक्वेशन मिळणार आहे? मॅक्झिमम मोनोक्रोमॅटिक इमिसिव्ह पॉवर ऑफ ए ब्लॅक बॉडी इज इक्वल टू 1.285 इंटू 10 रेस टू मायनस 5 टी रेस टू 5 वॅट पर मीटर स्क्वेअर पर मीटर वेव्हलेंथ. पर मीटर वेव्हलेंथ. सो दिस इज द इक्वेशन फॉर द मॅक्झिमम मोनोक्रोमॅटिक इमिसिव्ह पॉवर. आणि हे इक्वेशन कशावरून मिळाले आपल्याला? कॉम्बिनेशन ऑफ प्लँक्स लॉ आणि विन्स डिस्प्लेसमेंट लॉ, या दोन्हीचं कॉम्बिनेशन करून वी आर फाइंडिंग द व्हॅल्यू ऑफ मॅक्झिमम मोनोक्रोमॅटिक इमिसिव्ह पॉवर. ओके, so this is about the, we have covered the Planck's law and Wien's displacement law. Now we have to solve the two problems related to this. Okay, so write down the first problem. Write down first. Assuming, first problem, assuming the sun to be a black body, assuming the sun to be a black body. काय म्हणतात ते? ऍझ्युम करा की सन एक ब्लॅक बॉडी आहे. ऍझ्युमिंग द सन टू बी ए ब्लॅक बॉडी emitting radiation with maximum intensity at lambda is equal to 0.49 micrometer. Black body emitting radiation with maximum intensity at lambda is equal to 0.49 micrometer. Calculate the following. First, the surface temperature of sun. तर आपल्याला सनचं सरफेस टेम्परेचर फाइंड आउट करायचं आहे. सरफेस टेम्परेचर ऑफ द सन, the surface temperature of the sun. And second, the heat flux at surface of the sun, 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 the heat flux at surface of the sun. Okay, so first of all we have to write down the given. What is to be given? Assuming sun to be a black body, म्हणजे sun जो आहे तर त्याला आपण ब्लॅक बॉडी कन्सिडर करणार आहे, आणि इट इमिट्स द रेडिएशन विथ मॅक्झिमम इंटेन्सिटी ॲट wavelength is given. Whatever the radiation emitted by that sun, wavelength of that radiation is given 0.49 micrometer. Then we have to calculate the following: the surface temperature of the sun and the heat flux at the surface of the sun. Heat flux म्हणजे काय असते? What is the unit of the heat flux? That is watt per meter square. Means we have to calculate the emissive power of that black body. So we know that how to calculate the emissive power of a black body. EB is equal to sigma into T raised to 4. This is the standard equation. So by using that we have to easily calculate the heat flux. समजते बघा, हीट फ्लक्सचं जे काही युनिट असते ते वॅट पर मीटर स्क्वेअर असते, आणि आपली जी काही इमिसिव्ह पॉवर ऑफ ब्लॅक बॉडी असते त्याचं पण युनिट वॅट पर मीटर स्क्वेअर असते. म्हणजे हीट फ्लक्स कॅल्क्युलेट करायचं म्हणजेच आपल्याला काय कॅल्क्युलेट करायचं, वी हॅव टू कॅल्क्युलेट दी इमिसिव्ह पॉवर ऑफ ए ब्लॅक बॉडी. ओके, द युनिट ऑफ दी हीट फ्लक्स अँड इमिसिव्ह पॉवर ऑफ ए ब्लॅक बॉडी इज सेम. So for this case we have to calculate the emissive power, and that emissive power is nothing but heat flux for that surface of the sun. Okay, then we have to calculate the surface temperature of the sun. Okay, so by using the Wien's displacement law, maximum wavelength into temperature is equal to 2898 micrometer Kelvin. So in that equation, maximum wavelength is given, maximum intensity at lambda is equal to means lambda max is given, so lambda max into T is equal to 2898. So by using that we have to calculate the temperature. Then emissive power of a sun is equal to 6. What is the standard equation for the emissive power of a black body? That is sigma into T raised to 4. So by using that we have to calculate the heat flux. Okay, so all of you calculate this temperature and emissive power of the sun or heat flux for the sun. Okay, so write down lambda is given, T is question mark, and emissive power of sun, that is question mark. Then we have to use lambda max into T is equal to 2898 micrometer Kelvin. So put the value of wavelength, that is 0.49. So we get the value of temperature, that is 5914 Kelvin. Okay, then we have to use the equation for the emissive power of a black body, that is E sun is equal to sigma into T raised to 4. What is the value of sigma? That is 5.67 into 10 raised to minus 8 T raised to 4. And how to write that equation? 5.67 T upon 100 raised to 4 is there. By mistakenly I have written there square. So we have to write down T upon 100 raised to 4. Okay. So 5.67 into bracket. What is the value of temperature? 5914 divided by 100 raised to 4. So from that we get the heat flux at the surface of the sun, that is 6.936 into 10 raised to 7 watt per meter square. 6.936 into 10 raised to 7 watt per meter square. This is the heat flux at the surface of the sun. आणि सनचं टेम्परेचर काय असणार आहे? 5914 केल्विन. What is the temperature at surface temperature of the sun? That is 5914 Kelvin. 5914 Kelvin. Okay. All of you completed this problem. What is the value of temperature? 5914 Kelvin. And what is the heat flux at the surface of the sun? That is 6.936 into 10 raised to 7 watt per meter square. Watt per meter square. Okay. Then write down the second problem. Write down. Calculate the following. Calculate the following for an industrial furnace. Calculate the following. Calculate the following for an industrial furnace in the form of black body. Calculate the following for an industrial furnace in the form of black body. Calculate the following for an industrial furnace in the form of black body and emitting radiation at 2500 degrees Celsius and emitting radiation at 2500 degrees Celsius. 2500 degrees Celsius. Okay. First, you have to find out monochromatic emissive power at monochromatic emissive power at 1.2 micrometer length. First, you have to find out monochromatic emissive power at 1.2 micrometer length. Then second, we have to find out wavelength at which the emission is maximum. Wavelength at which the emission is maximum. Second, we have to find out the wavelength at which the emission is maximum. Then third, maximum emissive power. Third, maximum emissive power. Maximum emissive power. Maximum emissive power. Fourth, we have to calculate the total emissive power. Total emissive power. Fourth, we have to find out total emissive power. And fifth one, total emissive power of the furnace if, fifth we have to find out total emissive power, total emissive power of the furnace, total emissive power of the furnace if it is assumed, if it is assumed as a real surface, total emissive power of the furnace if it is assumed, if it is assumed as a real surface, as a real surface with emissivity equal to, with emissivity equal to zero point 0.9, with emissivity is equal to 0.9, emissivity is equal to 0.9. समजले का बघा. कॅल्क्युलेट दी फॉलोइंग फॉर अन इंडस्ट्रियल फर्नेस इन द फॉर्म ऑफ ब्लॅक बॉडी. जो काही इंडस्ट्रियल फर्नेस आहे त्याला ब्लॅक बॉडी कन्सिडर करा म्हणून सांगितले आणि त्याचं टेम्परेचर दिलेलं आहे 2500 डिग्री सेल्सिअस. सो बाय युझिंग दिस इन्फॉर्मेशन वी हॅव टू फाइंड आउट दी मोनोक्रोमॅटिक इमिसिव्ह पॉवर, then wavelength at which the emission is maximum, then maximum emissive power, then total emissive power, and then total emissive power of the furnace if it is assumed as a real surface with emissivity is equal to 0.9. So we have to find out these 5 values by using the given information. Okay, so first of all you have to write down the, first we have to find out the monochromatic emissive power at 1.2 micrometer length. Okay, so write down first monochromatic emissive power, monochromatic emissive power at, monochromatic emissive power at 1.2 micrometer length. ज्यावेळेला 1.2 micrometer length we have to find out the मोनोक्रोमॅटिक इमिसिव्ह पॉवर. म्हणजे 1.2 मायक्रोमीटर लेंथ म्हणजे काय आहे तर ती वेव्हलेंथ आहे. सो फॉर दॅट वेव्हलेंथ वी हॅव टू कॅल्क्युलेट दी मोनोक्रोमॅटिक इमिसिव्ह पॉवर ऑफ ए ब्लॅक बॉडी. And we know that what is the standard equation for the monochromatic emissive power of a black body. So E lambda B is equal to C1 lambda raised to minus 5 divided by exponential of C2 lambda T minus 1. तर ह्या इक्वेशन मध्ये C1 ची व्हॅल्यू आपल्याला माहिती आहे, C2 ची व्हॅल्यू माहिती आहे. C1 ची व्हॅल्यू वॅट मायक्रोमीटर रेस टू 4 डिवायडेड बाय मीटर स्क्वेअर मध्ये वेगळी असणार आहे आणि वॅट मीटर रेस टू 4 डिवायडेड बाय मीटर स्क्वेअर ह्याच्यामध्ये वेगळी असणार आहे. तर त्या दोन्ही व्हॅल्यू लिहिलेल्या आहेत. त्याच्यानंतर C2 ची व्हॅल्यू मीटर केल्विन मध्ये काय असणार आहे 1.4388 इंटू 10⁻² मीटर केल्विन. Okay, so put this value into the equation. C1 is known to us, C2 is known to us, then lambda is given and temperature is given. So put the all the values into the equation. We get the equation as a monochromatic emissive power. तर ते monochromatic emissive power आपल्याला काय मिळणार आहे 2.014 into 10⁻². 2.014 into 10⁻². समजले का बघा. C1 आणि C2 च्या व्हॅल्यू स्टँडर्ड आहेत. टेम्परेचर दिलेला आहे, वेव्हलेंथ दिलेला आहे. सो ऑल पुट ऑल दिस व्हॅल्यू इनटू दिस इक्वेशन अँड फाइंड आउट दी मोनोक्रोमॅटिक इमिसिव्ह पॉवर ऑफ ए ब्लॅक बॉडी. फर्नेसला ब्लॅक बॉडी कन्सिडर करा म्हणून सांगितलेलं आहे. सो ई लॅम्बडा बी इज इक्वल टू वी गेट दी व्हॅल्यू ॲज ए 2.014 इंटू 10⁻². सगळ्यांनी कॅल्क्युलेशन करून बघा ही व्हॅल्यू करेक्ट आहे का. ओके, सो ई लॅम्बडा बी इज इक्वल टू C1. C1 ची व्हॅल्यू काय आहे तर 0.3742 इंटू 10⁻⁻15 इंटू लॅम्बडा रेस टू -5. लॅम्बडा काय किती दिलेला 1.2 मायक्रोमीटर म्हणजे 10⁻⁻6 रेस टू -5 divided by exponential of what is the value of C2 that is 1.4388 into 10⁻² divided by lambda into T. Lambda is nothing but 1.2 मायक्रोमीटरचं कन्वर्जन करायचं मीटर मध्ये म्हटलं तर 10⁻⁻6. सो 1.2 into 10⁻⁻6 into टेम्परेचर इज गिवन. सो व्हॉट इज द व्हॅल्यू ऑफ टेम्परेचर 2500 डिग्री आहे तर त्याचं केल्विन मध्ये कन्वर्जन केलेलं आहे 2773 ब्रॅकेट कंप्लीट -1. ओके, तर एक्सपोनेन्शियल ऑफ दॅट टर्म -1 आहे. त्या पूर्ण इक्वेशन मधून -1 करायचं लक्षात ठेवा. ओके, so from that we get the value as a 2.014 into 10⁻12. So this is the first value. Then we have to calculate the second wavelength at which the emission is maximum. Wavelength calculate करायचे maximum wavelength. So by the using the winds displacement law, like maximum wavelength into temperature is equal to 2898. So from that maximum wavelength is equal to 2898 divided by temperature. So what is the value of temperature? 2773. So from that we get the wavelength, that is 1.045 micrometer. Okay, so all of you write down wavelength at which the emission is maximum. So lambda max is equal to 2898 divided by temperature. So temperature is given, that is 2773 Kelvin. So from that we get the value as a 1.045 micrometer. ही झाली वेव्हलेंथ. वेव्हलेंथची व्हॅल्यू काय येते लिहून घ्या सगळ्यांनी, 1.045 मायक्रोमीटर. 1.045 micrometer. Okay, then we have to find out the maximum emissive power. ओके, सो आपण मगाशी कॉम्बिनेशन करून विन्स डिस्प्लेसमेंट आणि प्लँक्स लॉ आपल्याला एक इक्वेशन मिळालेलं, मॅक्झिमम इमिसिव्ह पॉवर. व्हॉट इज दॅट इक्वेशन? ई लॅम्बडा बी मॅक्स इज इक्वल टू 1.285 इंटू 10⁻⁵ T⁵5 वॅट पर मीटर स्क्वेअर पर मीटर वेव्हलेंथ. हे आपल्याला इक्वेशन मिळालेलं. तर याच्यामध्ये टेम्परेचरची व्हॅल्यू पुट करा, देन वी गेट दी व्हॅल्यू ऑफ ई लॅम्बडा बी मॅक्स. समजले? 1.285 इंटू 10⁻⁵. टेम्परेचरची व्हॅल्यू पुट करा 2773 आणि त्याचं युनिट काय असणार? वॅट पर मीटर स्क्वेअर पर मीटर लेंथ. सो वी गेट दी मॅक्झिमम इमिसिव्ह पॉवर ॲज ए 2.1 इंटू 10⁻12. 2.1 इंटू 10⁻12 वॅट पर मीटर स्क्वेअर पर मीटर लेंथ. समजलं बघा, मगाशीच आपण इक्वेशन डिराईव्ह केलेलं आहे, तर त्या इक्वेशनचा इथं आपल्याला यूज केलेला आहे आपण इथं मॅक्झिमम इमिसिव्ह पॉवर फाइंड आउट करण्यासाठी. ओके, then next fourth is total emissive power. So we know that how to calculate total emissive power of a black body, that is sigma into T⁻⁴. So EB is equal to sigma into T⁻⁴. So what is the value of sigma? 5.67 into 10⁻⁻8 into what is the value of temperature? 2773 raised to 4. Okay, so from that we get the total emissive power, that is 3.352 into 10⁻⁶ watt per meter square. Okay, so this is the total emissive power. And then next we have to calculate the total emissive power with emissivity is equal to 0.9. Epsilon is given 0.9. So for the calculating the emissive power, when emissivity is given, then we have to multiply that equation by the emissivity. So emissive power is equal to epsilon into sigma into T⁻⁴. Epsilon into sigma into T⁻⁴. So emissivity is given 0.9. So 0.9 into, already we have calculated the value of sigma into T⁻⁴. So we have to directly take the product of that. We get the total emissive power when emissivity is equal to 0.9. That value is nothing but 3.017 into 10⁻⁶ watt per meter square. समजले का? बघा, ही इक्वेशन लक्षात ठेवा. मॅक्झिमम इमिसिव्ह पॉवर कशी कॅल्क्युलेट करायची, टोटल इमिसिव्ह पॉवर कशी कॅल्क्युलेट करायची, इमिसिव्ह पॉवर ज्यावेळेला इमिसिव्हिटी दिलेली असणार आहे त्यावेळेला कशी कॅल्क्युलेट करायची. सो दीज आर द इक्वेशन्स बाय युझिंग दॅट वी हॅव टू कॅल्क्युलेट दी इमिसिव्ह पॉवर्स. मॅक्झिमम इमिसिव्ह पॉवरचा फॉर्म्युला वेगळा आहे, टोटल इमिसिव्ह पॉवरचा फॉर्म्युला वेगळा आहे, इमिसिव्हिटी दिल्यानंतर टोटल इमिसिव्ह पॉवर कॅल्क्युलेट करायचा फॉर्म्युला वेगळा आहे. Okay, so by using these equations we have to calculate the emissive powers as per the conditions. Okay, so here we have completed the laws of the radiation. We have completed the 4 laws of the radiation, that is Stephen Boltzmann, Kirchhoff's law, Planck's law and Wien's displacement law. Now in the next lecture we have to see the surface emission properties, that is total emissive power means what, monochromatic emissive power, then emission from real surfaces, then emissivity, then what is meant by solid angle, then intensity of radiation, then Lambert's cosine rule. That part we have to cover in the next lecture. Okay, so thank you very much. All of you put your roll numbers in the chat box.